All right, sorry, this screen is messed up. Somebody hit it with the door. Should have known that would happen, I guess. There's no door stopper or anything. Let's talk a little bit more about NFAs and regular expressions. This is what we were talking about towards the end last time, which was some time ago, I suppose. NFA and regular expressions. Specifically, we were talking, first of all, about converting regular expression to NFA. All right. If you know what to do, this is not so difficult. Going the other way around is another matter, but let's just refresh our memory about this. It really comes down to remembering how to represent the two operations, the plus and the star. So I will just refresh our memory. If you have something like R1 plus R2, the way to structure that in an NFA is like this, two branching paths. So you put whatever the thing is for R1 and R2, and then you tie them together with epsilons into an accepting state here. The reason we tie them together at the end is so that this whole thing as a block can be sort of slotted into some kind of larger diagrams if you want to. And then the star looks like you sort of put this in the middle and make this kind of loop sort of a thing. It can go through the R, and then if you want to, it can loop, go back to the beginning, and then go through the R again. That's what a star is all about, repeating this thing. And the star also is allowed to do this 0 times, and to achieve that, you also need a forwards epsilon. That lets you just skip over the R entirely. This sort of little burger shape is how you do a star. And then for any regular expression that I give you, it's just a matter of patching together the various pieces, and it'll always be, any regular expression is just a bunch of pieces combined with pluses and stars. So you just sort of build the thing as necessary. So for example, if I wanted to do an NFA for this A, B star, A plus B, all right? So this is a regular expression for strings which begin with A, and then they have 0 or more blocks of AB. And then finally they finish with just an extra A or an extra B. All right, so let's try to make an NFA with that. First of all, I see 3 bits which are sort of one after another, right? Those on the diagram, you just put them one after another, connected by epsilons. So we begin with the A, then we have AB star, so maybe just I'll write each individual little piece. AB star, if I was doing a diagram for that, it would look like this, A, B, like this, and then a backwards epsilon and a forwards epsilon, like that. This is an AB star. Now, I suppose if you were copying my description, this thing, which I called the burger thing, you may have been expecting me to put epsilon and then A, then B, then another epsilon, which is what I said here. And you can do that if you want to, although extra epsilons like that, I'm often going to leave them out because I hope nobody minds if I leave out those extra epsilons. All right, so that's how you would do AB star. How about this A plus B at the end? It would look like that's just this, right? If you like, it could be like this. A, B, and then coming back together. All right? And so how do we combine all of that? Remember, I wanted A followed by AB star followed by A plus B. It's just these things, but sort of one after another, and we start with an extra A at the very beginning. So my final answer for A, AB star, and A plus B should look like, okay, here's my starting state, A, and now I go into that AB star thing, which is A, B, with the epsilons. That's AB star. And then finally I go into the last bit there, which is a plus b. Maybe I'll put a little epsilon here. Some of these epsilons could be abbreviated, although I don't care so much if you do. And there's my accepting state. All right, so that's how we sort of piece everything together. Any questions about all of it? This is making an NFA out of regular expressions. This can sometimes result in fairly big diagrams, but it's not, you don't have to think too hard to do this procedure, in my opinion. All right, I got one for you all to try. Let's make a NFA for this here. A squared plus B star BA plus epsilon. See how you like that. I would suggest you try and break it up into smaller pieces. Maybe draw some diagrams for the smaller pieces and then patch them all together into a big thing. I'll give you a few minutes to see how you feel. Walk around and see how you're doing in a moment. It's kind of like inside this burger shape. All right. This is good. I think you probably need to start. Yeah. All right. It's really all of this stuff is together and then plus that. Okay. Yeah, that's pretty good. All right.
circles.
Alright. Okay. Mhm. That piece of it. Alright. Yeah, that's epsilon. Can I just say that this is, you're not supposed to put a squared. It should be AA. Just be, yeah, like these two tracks, they don't have that. Okay. It's very much like that. This particular case, that or epsilon means you want to, you want to be able to go from all the way.
Yes, this is what this is how you're supposed to do it, but because it's just the absence of.
Yeah, the arrow.
I'm saying
What you
that's
had
how
is
you're
you
supposed to
can
do
go
it.
through, so you go back and goes all the way through the which is doing okay?
I just, you can do either. Yeah, see, that's what I'm saying. You could also do that.
Yeah, you just go straight to the example.
Because two epsilons in a row,
Yeah.
you can do anything, right? You're doing nothing versus one.
Yeah.
Literally start with
Yeah, I'm saying, like, you're good. I mean, what's that probably? I figured
You
you
either-
did that.
you either do
That's what I
that
Doing
wanted.
okay?
That's why I
Yeah, that's
wanted
great.
to look, like,
Perfect.
perfect.
Alright, can we talk about this one? I've seen some good ones out there. A squared plus B is, I'm going to try, I hope you don't mind if I just try and write the whole thing. A squared plus B is one of these branching paths with A squared across the top and just B across the bottom. And so that right there is A squared plus B. And then if I want that inside of a star, I make the burger around it, which goes back this way and this way, right? So this, what I've got so far, is A squared plus B star. And now I want that to be followed by BA, which is easy enough. I can just go BA like this. And it's all of this stuff or epsilon. So if I have a plus there, this plus should also be a split path where the first half of that path is all of this stuff. So really, I'm going to put two branching paths, right? And the second one is just nothing, or it's just epsilon if you like, and that's my accepting state. So this is how I did that. There are other ways that you could have drawn by using fewer epsilons, and that's probably fine. Yeah.
Could you explain for the A squared plus B star why I can't just have the second A go to the last state?
This A just goes here.
Yeah, why you can't just
You can do that if you want. Yeah. So I would say, I left out an epsilon here. This epsilon arrow and this one are a bit superfluous. You could just make this arrow go here and this arrow go here with a B label. That's fine. Yeah. All right. I hope everybody got something like that. This is how I would have said it. Of course, this epsilon and epsilon could be condensed into a single epsilon arrow. Oh, I didn't write my starting state. Is there. All right, great. So this is how to convert a regular expression to NFA. All right. It always, like this will always work, provided that you can, structure your diagram properly based on the operations. What about going the other way around? If I give you an NFA, can you sort of convert that back into a regular expression? Now, if the NFA already looks like this, like if the NFA happens to be built out of these kind of burgers and branching paths, then you can switch it back. But maybe there's not every NFA looks like that, right? You can do it on at least some. Like here's an example where we can do it. How about NFA back to a regular expression? This is the other way around. And how about, this is an example, somewhat complicated example that was on the homework. a while ago. It had names for the states. Actually, the names don't matter in this when you're thinking about writing it again as a regular expression. All right, here is a NFA. Can I write this as a regular expression? Actually, you can write this as a regular expression. The way that you should think about this is, I would say, we must describe all possible paths from Q0 to Q6, right? Because those are all the strings which are going to be accepted. Any accepted string has to, begin in the starting state, Q0, and end over here in the single accepting state. And this particular NFA is kind of nicely structured in that all the arrows kind of go from left to right, all right? So we don't have to worry about some weird looping paths, but we can, without too much trouble, actually just describe all possible paths from Q0 to Q6. You can go, for instance, it's very easy to describe what are all the possible ways going across the bottom. You can do this. There is only one, right? So on the bottom, a regular expression that describes the paths across the bottom is just BA, right? And across the middle, it's just ABB. And what about across the top? This is very slightly more complicated, but you can still write it as a regular expression. Anybody think? Sorry, I scrolled off some of the top. Can you write a regular expression describing all possible paths across the top? Yeah, what do you think?
Is it ABA plus B?
ABA plus B. I wasn't going to say it that way. And I think it's not. So you could do ABA. You could also do just B by doing epsilon B epsilon. But you could also do epsilon BA. Or you could do AB epsilon. You could write all those things, but I think there's a cuter way to say it. Anybody have another idea?
Did you say A or epsilon, B or epsilon?
Yes, this is what I was going to say. A plus epsilon, she said or, but B followed by A plus epsilon, right? That first arrow can be an A or epsilon. The middle arrow has to be a B, and then the last arrow has to be another A plus epsilon, okay? These are all the possible ways you can go from the thing on the left all the way to the thing on the right. And so my regular expression for the whole thing is just those three as branching paths. So I'm going to combine all of those with a plus. So the whole thing will just be BA plus ABB plus A plus epsilon B A plus epsilon. All right? Because the whole thing, that example was conveniently structured as just three different branching paths with no other funny business. All right? And so in that case, it's fairly easy. It's a little more difficult if, I will say, what if there are loops? See, what made this one easy is there were no looping paths. Every single path in the diagram just goes from right to left, and that's it. So it was easy to describe in terms of just three branching paths. But if there are loops in the diagram, this is more complicated. Let's just try, how about this one? It was also simpler because there was only one accepting state. If there's more than one accepting state, then you have to consider all the paths to any of the accepting states, which is, again, more complicated. But anyway. All right, here's one with loops. In this case, I would say you have to kind of try to think about the sort of loop structure of the diagram. I would say there are basically two loops that I see here. There's this one around the triangle, and then there's just this single edge loop here. All right, so we have two loops. There's this one, which I could write as a regular expression. And of course, when you see loops, you're going to use the star. So this loop I would write as ABA star. That's how you go around that loop, is by doing A followed by B followed by A. All right? And then there's the other loop, which is just this one. And what's a regular expression describing that one?
A star.
Just A star, right? That's a loop which consists only of A. So this would be A star. And now, how do I kind of put those together to get a regular expression for the whole thing? Well, it's kind of like you add these, because when you start here, you can go around this loop and still be accepted, or you could go around this loop several times, or you could go around this loop and still be accepted. I want to combine these by adding them. Now, when I add them, it's not just, so let me just say, not A star plus ABA star, because that would mean either you go around this one a bunch of times or you go around this one a bunch of times. But actually, you're allowed to sort of mix and match them, right? In order to end up in the accepting state, I could do the triangle a few times, then do this little loop a few times, and then the triangle again. So how would I express that as a regular expression? Yeah?
A star, ABA star, A star.
That is still not complicated enough. I think what you just said, he said A star, then ABA star, then A star. That would let you do the loop, then the triangle, then the loop again. What if I wanted to do then the triangle again? It needs to be a little more complicated than that. Yeah.
It would be A star plus ABA star star.
Yes, and in fact, you don't need all of those stars. But basically, you take this and wrap this inside of another star. And once you do that, you don't actually need the inner stars anymore. But it's like this, all right? Those are the two loops, and you can do either one over and over again, and you can mix and match them if you want to. So I put the two loops with a plus inside of a star. That means any repetitions where you do the first little loop or the triangular loop. Yes?
Would A star be A star also work here?
A star, B, A star. I don't think so. Although, yeah, not quite. This is a good idea, though. He said A star, B, A star. What we're trying to write is a format for all accepted strings. But this would include, for instance, B, just B, which is not accepted here. So, yeah, it's a little complicated. There may be some other way to write this. I think what you're sort of getting at is the fact that like this A, somehow this A and this A, maybe they can be somehow combined together in the regular expression in a cute way. I'm not sure that's actually possible. Maybe it is. I don't know. So don't do that. All right, this is the answer. So actually, it is possible to turn any NFA back into a regular expression, but it's quite a bit non-obvious how to do this. And so I'm going to write that down, NFA to regular expression is always possible, but sometimes hard. And I don't really want to go into the details. So if you read in our book, they describe how to do this in easy examples, and then they say, if you want to learn the general procedure for all possible examples, you should read the appendix. And in the appendix, they give this extremely detailed algorithm for converting a general NFA to regular expression, which in my opinion is not very illuminating. It is possible to do this in all cases, but I don't think I want to get into the details of that. So doing it is always possible. I will just say sometimes it's a pain. I wanted to do a few more examples just that we can do without too much trouble. So in small examples, it's not so hard to do. In a really big one and complicated one, they can be kind of taxing. So what I see here is, how about that? Here's the starting state. All right, again, you want to think of this in terms of loops. in terms of loops on the accepting states, really. So what I see here is sort of my first impression when I look at the diagram is you must do B first, and then some loops are possible, right? So the only way to be accepted is if it starts with a B. Once it begins with a B, then there's some kind of a mixing and matching of loops where, again, I have two possible loops. There's just the A loop, and then there's an AB loop. So what I'm going to write is something like B first, followed by some loops here connected by pluses, all right? I want this to be, it'll end up looking similar to the previous example here, which had two possible loops on the, in that one they were on the starting state. Here they are moved over by a B. Anyway, what anybody see how this is going? What do you want to fill in the blank there? Yeah?
A plus AB.
Yeah, A plus AB. Those are the two kinds of loops that I can do. So you must do a B first, and then once you arrive here, you have your choice of doing these two loops over and over again. And that's how it goes. All right, here's another one. How about this one is slightly more complicated. It's almost the same, but the only difference is this extra little guy over here. This is the same diagram again, but I added this thing right there. It's going to look pretty similar though. We must begin with a B. That's what I can tell by looking at the diagram. You have to start with a B, and then there's some amount of loopy-doopies that I'm going to put inside the parentheses connected by plus. I hope it's non-controversial to start with A plus. That's this one, right? So you can still just do this one however often you want. It's the other one which is a little stranger. The other one now, it used to be just A followed by B, which is easy to express. Now it looks like A, then some more A's maybe, followed by a B. Anybody, any idea how we could write that? What I want to write here is an A followed by possibly some more A's and then a B. What do you think? A star B, I like that. Yeah, so this is sort of a loop inside of a loop, but this is how you handle that. We have to go A first, and then maybe do some more A's, and then go back here with a B. Yeah. All right. I got one more. Sorry, I got two more, but how about this one? So, again, you should look at this and try to think on some kind of large-scale level about the loops. In the previous two ones that we did, so in this previous one, you had to do something followed by some freedom in terms of doing the loops. I would say in this example, I have optional loops at the beginning, but then you have to finish with A, B, right? This is how I would think about the general structure of the diagram. You have loops that you can do at the beginning, but they must finish by doing A, B. So my general structure will look something like this. Some kind of loops at the beginning, ending with A, B in order to be accepted. And I put the star there because that's where the loops are happening. And then you just have to think about what are the individual loops that you're allowed to do there inside of that star, and connect them up with a plus. Anyone got an idea? What do you think?
A star, B star, plus B, B star.
I think you don't need those stars. Well, maybe. Okay, he said A star, B star, plus B, B star?
Yeah.
B. So because I have this star out here, I would rather just write BB like that. Now this is not exactly what I was going to say, although I think this is probably still correct, but would you mind if I say, what I was going to say is A plus B, like that. So I see this little loop here, and what that means is you either do A or you do a B. And so it can either be A or B, which means A plus B. Now, he said A star, B star, which is also correct because that would represent going around this little loop many times with an A and also many times with a B, and that's fine. Although, in my opinion, this is a little closer to what the diagram says. All right. Yeah, this is what I would say for this one. This one, the diagram is a little silly because in this case, there's actually no reason on the diagram to go BB on this thing because you could just do this BB up here. So there's some redundancy in the arrow. So if you feel like, isn't this BB redundant with this B? The answer is kind of yes, because rather than doing two B's at once, you can do this B individually twice with the star here. But just directly translating the diagram to a regular expression, it would look something like that. All right. One last example. I thought this would be fun. Maybe I'll have you guys try this one. How about a regular expression to match any binary number divisible by 3? Remember this old example of we did this with a DFA, which accepts any binary number that's divisible by 3, and I will refresh our memory. This is what it looked like. See if you can do it. Can you convert this into a regular expression? It's going to use ones and zeros, not A's and B's. This is a DFA, of course, although usually we do this for NFAs, but you can do it for DFA too. There's no difference because every DFA is automatically an NFA. See what you think. Thinking about all the possible loops that you can do to go around back to this accepting state. do 1, 0, 0, 0. You have it going on. Make sure that your regular expression should accept this. Does it? That would be 1, 0, 0, 0, 0, 1. Should be accepted. See if can you handle that? Feel free to talk to your friends. Okay.
Really? So another one for just the zero, one for zero.
Yeah.
Just one.
Yeah.
How'd you do it for if you're going 1, 0, go around many times here, then come back and then do one here and one again?
I would say, yeah, you want to put this in the star.
Sounds like something like this.
I would say, yeah, something in there. Gotcha. Doing okay? Yeah, that's pretty good. But consider my. Yeah, that's good. One more thing is, I like this 0, 0 star. Yeah. Oh, this is good. This is if you don't repeat this. Just go here. So I'm not saying here, while you're repeating the zeros, you should be allowed to do some of these. So if you do 0, 0, 0, 0, 0, 1, 0, 1, 0, try and insert that in there. Doing okay? Yeah. Yeah. I would say these guys need to be a little more complicated. Like this 0, 0, I think really what you mean is 1, 0, 0, 1, because that's this. This 1, 1 can do that. You also want to do this, which would be 1, 0, 0. I didn't get all the way around, but let's talk about this. So I tried to indicate some various paths here. There's just the single 0, which I'll put as a little guy by itself. And then you could do just the 1, 1, which I would write as a 1, 1. And then you could also do this path that I marked in blue, 1, 0, 0, 1. Right? This is a good start. Now, one thing is that this does not make any reference to this little guy here. Any idea? How could I incorporate this little guy into this stuff? Yeah?
Just say 1, 0, 1 star, 0, 1.
Yeah, 1, 0, 1 star, 0, 1. And in fact, that I can just squeeze that into this one, right? Because it's really the same as this, but with a 1 star in the middle. Like that, right? So this says you can go all the way out on the blue one, and then when you're over here, you can do this extra little 1, and it can come all the way back. All right? This is still not quite right because of this little example here. Does not fit in this pattern. Anybody have a way to get around that? You want to possibly allow for the zeros here to be repeated a bunch of times. You got an idea?
I don't know if this is right, but I did something like 1, 0, and then in parentheses 1 plus 0, 0 star. And like 0, 1.
This is not what I was going to say, but I think I like the looks of that. 1, 0. That might be correct. It's hard to tell. Anybody have another idea? This might be right, although I don't really like it that much. You have another idea?
I don't know if this is right. 1 and then parentheses 0, 1 star, 0, and parentheses star, then 1.
Yeah, this is what I was going to say. It's a little strange, that somebody can say something so cryptic and ridiculous looking, and I will say, yes, that's exactly what I was going to say. But this is exactly what I was going to say. You can go, so what it says is, you can do the 1 here to get there, and then from here, you can do any amount of 0, 0 with possibly an extra 1 in the middle, and that's what this star here means. You can repeat this thing as much as you want right here, and then eventually you got to do the last 1 there. So really, this thing can go in place of that. This is a better version of what I had there before. Right? I consider this a little tricky. Yes?
Can't that also incorporate the 1, 1?
Yes, this is what I was going to say. This one actually makes this redundant because the 1, 1 is what you get if you take 0 repetitions of this star in the middle here. And so actually once you have that, you don't need the 1, 1 anymore. So I think this is as simple as that can get. This is a hard one in my opinion. And this piece here may very well be equivalent to this, although I'm not sure of that. If you gave me this answer on a test, I would sit there and think for 10 minutes if this is really the same or not. If you said it during class, I would say, I don't like that, and ask somebody else for an answer. Yeah, this might also be right. I hope you don't mind me disliking it. All right. This is my final answer. Great. So the moral of the story is, it is always possible to convert NFA to regular expression, but sometimes it's not obvious, and sometimes there are lots of very picky details that you need to be careful about, and I don't really want to get into hard examples. Yeah?
Do we have to indicate that you can do more zeros at the end?
More zeros at the end, it can be accomplished using this
Okay.
in the star, right? Because this star, you can do this zeros first, but you can also do them after you do some of those. Yeah. So you don't have to say anything special about that. All right. Great. So I would just like what I'm saying here is that any regular expression can be converted into an NFA, and of course we already talked about converting. No, what we already talked about was converting regular expression into an NFA. That's easier. You can also go back the other way, NFA to regular expression. What that means is this constitutes a proof of this theorem here. Any language, sorry, that says language. Any language expressible by regular expression can be made into an NFA, which means it is a regular language. Remember, regular language means it is the language of a DFA or NFA. And what we've said so far is that you can actually convert back and forth. Any regular expression is equivalent to a certain NFA, and any NFA is equivalent to a regular expression. What that means is that any language expressible by a regular expression is a regular language. And actually, that's why, historically speaking, that's why these are called regular languages. I believe the history of the subject, the regular expressions were invented before NFAs and DFAs. And that's why these things are called regular languages, because they are the ones which are associated with regular expressions. All right? This is called, there's a name for this theorem. This is called Kleene's theorem. This guy, this is a person's name, Kleene. Kleene invented regular expressions and proved some theorems about them, such as this one. All right. What this means is that, I said before that regular expressions are super useful in the real world and used often in the real world to accomplish ordinary programming tasks that would be a pain to do using other methods. What that means is, this means there are some languages that you just cannot generate using regular expressions. Some languages can't be made with regular expressions. because there are some languages which are not regular. The classic example of that is this language, A to the N, B to the N. This is the only example actually we've talked about so far which you can prove is not a regular language. There's no DFA which accepts this language. This is not regular. So no regular expression can match that language. All right, this might seem to be bad news to real-world programmers because somebody who really likes using regular expressions to do stuff in the real world, like play Wordle or whatever, you are not going to be able to use regular expressions to handle a language like this. Although there are, for this reason, actually real-life regular expressions have extra operations built into them, which allow you to do more stuff. And those things, I didn't use any of those things, but I will just say real life regular expressions includes more sort of extra features, extra operations, which actually would allow you to match that language that I wrote there. In fact, they can allow you to match pretty much any language that you could think of. More extra operations, which I don't want to get into the details of, but there are ones where you can sort of use parentheses to enclose a piece of a regular expression, and then later on in the same regular expression you can refer back to the piece that you referenced before. That's called a back reference. Back references. That is when you use a certain piece of a regular expression at the beginning and you use it again later on in the regular expression. This is an operation which is not allowed just using the plus and the star, but in order to make these things more useful in real life, people have added extra features to standard regular expression things like grep in Unix. All right, great. So this ends our discussion of regular expressions. They are interoperable with NFAs and DFAs, although sometimes it can be difficult to convert NFA to regular expression. Anybody got anything more to say about regular expressions? I kind of like regular expressions, if you ask me. In my real life, I use them. In my own personal life, in my marriage, not really, but I have used them in my own personal life. More so than any abstract mathematics that I know, which is kind of a shame since that's sort of my jam, but not terribly useful in real life. Regular expressions are very useful in real life. Okay, let's talk, I would like to talk now in more detail about non-regular languages. It's perhaps, I don't know if it's a disappointment to you to look back on what we've done so far in the class and ponder about what kinds of languages have we discussed. We've discussed basically three types of machines, the NFA, the DFA, and the regular expression. But they all generate the same bunch of languages, the regular languages. And I said several times that it's actually very hard to show that a language is not regular, but we're going to talk eventually about doing that. This is the day that we've all been waiting for. I want to talk in detail about, if I show you a language, can you prove that it either is or is not a regular language? The specific thing to talk about is non-regular languages, such as A to the N, B to the N. The method for showing a method to show that some L is non-regular is based on it's sort of an abstract concept, which I would like to talk about first, and which unfortunately will take more than 20 minutes for me to discuss. Do you have a question? Oh. It says, my computer has not been restarted in more than 7 days. Please restart as soon as possible. I get this notice from ITS every 7 days. And then when I ignore it, every 1 day. I've been ignoring it for a few days. They want me to restart my computer once a week at least. And I refuse sometimes. Anyway, this is a method to show that some language is non-regular, all right? This involves some amount of abstract business that we need to talk about first, and it's not going to tie back within the next 20 minutes. So you can consider what we're about to begin just some kind of weird abstract thing, which is called, and it has a weird abstract name. This is named after a Polish mathematician. Named this. Anybody know how to pronounce Polish? Say this is something like Brzozowski. The RZ sounds like zh, and the B sounds like B, so it's bzh. Brzozowski. This is called the Brzozowski derivative, which I'm just going to call the derivative. It is unrelated to the derivative from calculus, although there are some rules for this kind of derivative which resemble the rules for the derivative in calculus. Although the resemblance, in my opinion, is somewhat superficial. There's not like a very deep connection between this and the derivative from calculus. But this is a thing that you can do for languages. You can take the derivative of a language. And you can take the derivative. So if I give you a language with like A's and B's, I can say take the derivative of this language with respect to A, or take the derivative with respect to B. And the result is another language. This is how this derivative works. And this derivative is based on asking a very weird question about DFAs. So a strange question about DFAs. What happens to the language of some DFA when we move the starting state? On its surface, there is no real good reason to ask this question, but this turns out to be super useful when it comes to this non-regular languages business. What happens to the language of some DFA when we move the starting state? So, for example, here's a DFA. I'm going to draw a DFA with 5 states here. Sorry to be slightly complicated about it. All right. So this is a DFA here with the starting state in the upper left corner, as I usually do. Anybody think you can tell me this is a DFA? What's the language of M here? You can say in words if you like, or write it like a set. What do you say?
A, B, and then parentheses B, to the N, when N is all real numbers.
BBB to the N. Yeah, so you got to do A first, and then you have this loop here. So this would be any A followed by a multiple of 3 B's. This is how I would say it in words. Or like he said it, you could write A, B cubed to the N, where N is any natural number. Something like that. I suppose you could write this as a regular expression if you wanted to. It would be that, right? These are all equivalent. It starts with an A, and then you got to do 3 B's at a time in order to be accepted. All right. And now, so that's what we start with. What happens if we move the starting state? Let's say instead of starting here, I start over here at the accepting state. So if we move the starting state, I'll call this N now. And it's the same thing, only this one is now the starting state. Sorry to have to redraw all of this stuff. And I want to try to ask, what was the effect of moving the arrow? Really, I moved the starting state. It used to be here, and I pushed it across through this A arrow, right? And what is the effect of that? So now the language. Anybody else want to say, what's the language now? It's actually similar to this. It's just very, very slightly different from that. Anyone agree? It's much like this, but not the same. Yeah? Yeah, it just doesn't have this A anymore, right? In order to get to the accepting state, you no longer have to do that A. So the language now is just b cubed to the n. All right? This is a fairly simple example, but the moral of the story here is, if you move the starting state by pushing through an A edge, the effect on the languages here is the language, you just remove an A at the beginning of every string in the language. All right? That's the difference between these two things. So I'm going to try and summarize that. We moved the starting state through an edge marked A. What I mean is, the movement of the starting state from where it used to be to where it is now, it got there by going across one edge which had an A on it, all right? So we moved the starting state through an edge marked A, and the effect was that all A's at the beginning of the strings got deleted. That is to say, the strings used to look like ab cubed to the n, and now they look like just b cubed to the n. The a's got removed from every string of the language. Actually, this is the derivative with respect to a. This is what it does, all right? But we'll get to that eventually. So one thing that I would say is just being a little less specific than that. I think everybody can agree at this point. Moving the start state changes the front of every string in the language. In this case, we move the start state to delete the first letter of every string in the language. But it changes the front just because when you move the starting state, you're talking about modifying what happens at the beginning. So it changes the front of these strings. It doesn't change the back end of them, right? The rightmost side. It changes the leftmost side of each of the strings in your language. All right? What if in this example, so in this example, we started with strings like this, and I pushed the starting state through an A, and I ended up just deleting that A. What if I go back to this example here? What if instead of moving the starting state here, I moved it down here? Can we say what would happen then? I'm going to copy and paste. I hope you don't mind. What if instead of there, I moved it to there? I'll call this one P. M-N-O-P. I don't like O. So I skipped over to P. We moved now the starting state down here. Can anybody say what's the language now? Actually, the language now is very different. Any thoughts? Yeah?
Would it not be possible to have other arrows like going out?
Yeah, he said it's not possible, meaning that no string is accepted, right? It's not possible to start here and make it to the accepting state. That means that no string is accepted by this DFA, and so in this case, now L of P. What is it as a set? Yeah, it is the empty set, right? Because no string is accepted by this DFA now. All right. So the idea here is this is like starting with ab cubed to the n, and then removing an initial b from everything. Remember when I pushed the start state across that a edge, it was like I removed an initial a from every word of the string. Here it's like removing an initial b from every letter in the string because I pushed through this edge with a b. So this is like starting with a b cubed to the n and then removing any initial b from all strings. But those strings, to begin with, they never had b at the beginning. And so this just kills everything and you just get the empty set. And this is how this derivative works. But these strings had no b. They had no initial b. So we end up with the empty set. All right. So this, what this kind of operation on languages is doing is it removes the first letter, if the first letter is what you're talking about. It removes an A at the beginning or it removes a B at the beginning. And if there isn't an A at the beginning, it just gets rid of that string entirely. So what we're doing is something like, this was something like, all strings of the form x such that bx is in the language of M. That is, you look for every string in here which started with a b, and then you remove that b, and you see what's left over. And in this example, that was the empty set, because there is no string starting with a b in the language at all. But if you did this with an a, it's not the empty set. You would get just that b to the end there. Anyway, this is called the Brzezowski derivative with respect to b. All right, and we write it like this. Like everybody likes to write the derivative with respect to b of the language. All right, so let me just say clearly the definition here. I've been a little wishy-washy, I think, so far. I'm trying to convince you what this has to do with the diagrams, but here's the real definition of the derivative. So for a language L and a letter, let's say A, but it could be B or whatever, the derivative is defined like this. Derivative with respect to A of L, it equals all strings x such that AX is in L. All right, this is the definition of the derivative. Much easier than the definition of the derivative in calculus, which nobody likes. All right. So how I would say that in words, it means something like find all strings in L starting with A, and then remove the A. That's what this is. And if there are no strings to begin with that start with A, then you just don't get anything. All right? You consider all the strings in there which begin with a A, and then you take that A away. All right? So, for example, we have a few minutes here. Some simple example here. Let's just talk about that one we were just talking about. A b cubed to the n. All right? The derivative with respect to A, it means you look at all the strings in that language and you take away the A at the beginning and you say what's left over. And what's left over is just the b's part. B cubed to the n. All right? But the derivative with respect to b of that same thing, now this means you take all of those words which start with b, and you take the b away. But none of those words start with b, and so I just get nothing. All right? You get the empty set, and the reason it's the empty set is because no strings in L begin with b. That's how you do the derivative. You find all the strings which start with a b, and then you take that b away. But if there aren't any, then you just don't get any. All right? We can also do other derivatives. We can also do, and I don't think I even need to write the definition, but something like this. Derivative with respect to AB of L. This means the same idea. You look in the language for any strings which begin with AB, and then you take away the AB, and you give what is left over. Anybody think you can say what that is in this case? You should ask yourself, first of all, are there any strings in here which begin with AB? I think actually there are. Like most of these do begin with AB, because they start with A, but then they have a bunch of B's. So what does it look like when you take something like that and remove the A followed by the next B? Yeah?
B squared to the n.
This is close. B squared, he said. I think it's actually this. B squared followed by B to the n. Because sorry, no, I meant this. Like that. This looks weird. It's because if you started with something like this, which had A followed by a multiple of 3 B's, and I took away the A and then also take away one of the B's, then what's left over is 2 more B's and then followed by some multiple of 3 B's. All right? This you have to think a little bit about. But when I have something like A followed by a multiple of 3 B's, I'm taking away the first A and also the next B. What's left over is 2 more B's, then followed by some more B's, a multiple of 3. All right? How about derivative with respect to BA? This means now you look at the same language, you find all the words that begin with BA and then remove the BA from them. And what's left over? What do you say?
Empty set?
The empty set, yeah. Why do you say that?
Because it goes through phi first, which is just empty set.
Yeah, because here, what it means is you look for all the words that start with BA, but there are no strings in this set that start with BA, so you just get the empty set. Empty set. Huh? Empty set. All right, great. I had some cute, stupid examples. Sure enough, I misplaced them. I was going to finish our remaining 4 minutes with cute, stupid examples, but I don't see them. I was thinking, so here, maybe I can remember some of my cute, stupid examples. So cute examples. Let's say that this fancy E here is the set of all legal English words. Then I can do something like derivative with respect to A of this E, fancy E here. Contains things like, can anybody give me a string which is in this derivative set? Remember, derivative with respect to A, it means you consider all the ones which started with A and you take the A away. Can anybody tell me a string which is in this derivative? Somebody else. Your answer can be cute and stupid. That was the purpose of these examples. You got an idea? Yeah?
Corn,
Corn. Yeah. Why did you say corn?
because it with the acorn.
Yeah, because acorn is a real word. And so this came from acorn, but I deleted the first A. Now, corn is also a real word. That's not required, though, right? So it could also be something like pupul, because apple is a real word. And that's what you get by starting with apple and then taking away the A, all right? You could do something like derivative with respect to SH. This contains things. This would be words which start with SH, but you take the SH away, like, I don't know, ort, because short is a real word, right? And so on. Here ends. I had much stupider and cuter examples written down on my piece of paper, but you'll have to accept pupul and ort for now. All right, this is the derivative. We will talk next time about what this has to do with regular and non-regular languages. It has a lot to do with them, though. All right, see you all next time. Because there is no homework for today, that means there is no quiz on Friday. So relax.